Tutorial will show you how to place results from HyperChem into a database. So let's first of all build a molecule. You'll do a 6-membered ring here, and we'll put an oxygen on here, and we'll make ethanol or cyclohexanol. So there's cyclohexanol. Let's do a calculation, say PM3 calculation, compute the single point, and calculate the energy properties of this molecule. For example, the dipole moment is 1.36 dBs for this molecule. So now, supposing we want to put this into a database, we bring up the database package. We can put it into an existing base, or we can create a new database. Let's create a new database, and we'll call this my DB, for example. We need to have a table in here, and we'll create a new table, and we'll call that table my table. Now, the default entries in this database are the name of the molecule, its molecular weight, possibly we put in the HDF file and a HIN file in here, and things like that. It can figure out from the formula how many oxygens and how many carbons there are and so forth. But we can put additional fields into the database if we like. In particular, HyperChem state variables, there's a bunch of different variables that HyperChem knows about that we can just search through and add. For example, down here somewhere will be the dipole moment. So let's add the dipole moment as a field to the database. So this is the new database. We'll open it. It has no entries at this moment. Everything is empty. So what we'll do is we'll go tell the database to get a record from HyperChem. And so we just say new record from HyperChem. It asks for the name of the molecule. We haven't given this a name. If we'd given a name in HyperChem, it wouldn't ask us, but we'll call this cyclohexanol. And just say OK. And it created a drawing, a 2D drawing, based on the best job it could do from the 3D drawing. Going from 3D to 2D is actually harder than going from 2D to 3D, but it did create a drawing for this molecule to put in the database. We have some the formula and the name and the dipole moment, 1.36 dBs. So here's this entry in the database. We can add other entries. This particular one only has one entry, but we can close that table, close the database, compact it or not, don't bother, and it's now in the database. And we can come back tomorrow, find this database, open it, and get this cyclohexanol entry in the database along with its properties that we computed, like the dipole moment. So that's taking results from HyperChem and putting them into a database, including particular values of computed properties.